Alright guys, welcome back to another video. Today I'll be teaching you guys how to do oxidation reduction reaction. So there are four main definitions you guys should know. One is the term oxidation, which just basically means that a molecule loses an electron. Alright, so one example could be, let's say we have iron, copper, whatever, some transition metal with +2 electron, and then it now becomes +3. So from here we see that the reaction for iron is now more positive, meaning that we lose an electron. So this is the term for oxidation. Hence then reduction is you gain an electron. So now the compound, chemical, whatever is now more negative in that sense, because now it has more negative charges, more electrons in its system. So basically the opposite of the first one in a reaction. All right, and then oxidizing agent basically facilitates the oxidation. Basically, this compound reduces itself. And reducing agent facilitates the reduction. So this oxidizes itself. So basically, these two are more alike because the chemical that's been oxidized is a reducing agent, and the reduction of one compound is the oxidizing agent. All right, now we'll do some examples. The best way to do it is to break each charges. So for oxygen, it has a -2 charge. Hydrogen, each of them has a +1 charge. Because this compound here is neutral, it's 0. All right, and then our final here, we'll start with hydrogen. Because it's neutral, so overall the charge for each hydrogen should just be 0. Here, I believe either way, O2 is still negative. Hydrogen here is +1, and that leaves potassium to be +1. And now for here, we see that both oxygens, there is no net change in its electron, so nothing happens here. We notice that the potassium in the initial is now more positive. Therefore, this is an oxidation. And then we see here the hydrogen is now more negative. Even though here it's +1, we could just ignore that because we identified that H2O, the hydrogen here, is now becoming reduced in its gas phase. So therefore, we can say that for potassium, it's the oxidation and a reducing agent. Because in order for the hydrogen here to become a reducing, to be reduced to 0, you need potassium to first be oxidized in order then for the hydrogen from the H2O and to the gas to be 0. Therefore here it's your oxidizing agent. We'll start with this compound right here. Sodium has a +1 charge. Therefore, to make this whole compound neutral, bromine is -1. Cl2, the whole compound is 0 charge, so therefore Cl is 0. And now in its final stage, sodium is still a +1 compound. Chlorine is now a -1 because in order for this compound to be neutral, chlorine will have to be a -1. And finally, Br is 0. All right, from here we can see that Cl2 to NaCl, the chlorine went from a 0 charge to a -1 charge. So this is your reduction. And the Br here is now 0. So because this went from a -1 electron to a 0 charge, we lose that electron, meaning it's now a bit more positive. So this is your oxidation. All right, so for this example, we'll say O2 is -2 electrons. In order for Ag to compensate to be this whole molecules to be neutral, each compound for Ag should have a +1 charge. In its final stage, gold has a net of 0 and is by itself, so this has a 0 net charge. And O2 gas, because this whole end product is 0, both the oxygens are 0. All right, and so from here we see that the oxygen in the initial was a -2 charge, and now it has a 0 net charge. So this is your oxidation. And gold in the beginning had a +1 charge and is now 0. So therefore, this is your reduction. So I hope this was helpful. Yeah.